Welcome back to Steggo, Eggo, a podcast about dinosaurs and their relationship to the modern day. Today, we will be exploring the evolution of the Tyrannosauridae and their similarities and differences to modern-day birds like the ostrich.
Tyrannosauridae hails from the family of theropod dinosaurs and were common around 70 million years ago throughout the Cretaceous period. Members of this group also served as the apex predators of the time.
Tyrannosaurus rex was the most infamous of these dinosaurs. Standing at 12 to 20 feet tall and close to 13,000 pounds, the T-Rex was a terrifying figure throughout the Cretaceous landscape. Using their massive jaws and serrated teeth, the T-Rex could break through the bones and tissue of other dinosaurs with absolute ease, registering the largest estimated bite force of any terrestrial animal in history at 57,000 newtons, or 12,000 pounds. They could even run close to 20 miles per hour.
That's all very interesting and impressive, Isaac. But how can an animal like an ostrich possibly be related? Ostriches are less than half of the height, weigh only 350 pounds, and only have a bite force of 50 newtons. Not to mention, ostriches can run over 40 miles per hour and are omnivores.
Well, Maria, just because some details are super different doesn't mean that Tyrannosauride, like the T-Rex and ostrich, are all that different. For one, there has been over 65 million years worth of evolution. So, it makes perfect sense that they don't look or act particularly alike.
In addition to that, tyrannosaurs and ostriches share plenty of characteristics. For example, both have hollow bones. Could you imagine an ostrich running up to 40 miles per hour without them? Or massive beasts like a T-Rex to even move at all? Both animals also stand upright in this bipedal posture, which allows them to move with greater efficiency and ease, and have a more complete vision of their surroundings from a higher viewpoint. This also lets them use their arms for other tasks. Not that the T-Rex's short stubby arms would be useful for much of anything.
That's a great point, Leo, and this is where evolution becomes so important. When we look at creatures like the T-Rex and compare them to birds like ostriches, we're not saying that they're the same, but rather that they have a shared common ancestor. Evolution allows us to trace how traits are preserved, lost, or adapted over millions of years. It's like following a very long, very ancient family tree where each branch shows how species respond to changes in climate, food resources, and survival challenges.
Exactly. Without understanding evolution, it might seem ridiculous to compare a 13,000-pound predator to a bird that pecks at grass and sprints across savannas. But evolution explains how features like hollow bones, bipedal movement, and even feathers can appear in both. This is because they've been passed down, altered, and repurposed across a long period of time.
This all sounds so interesting, but if this happened so long ago, why would this matter today?
Well, the cool thing about learning about the past and evolutionary history is that it helps scientists make sense of how animals adapt or struggle to adapt to changing environments, including the ones humans are impacting now. It also deepens our understanding of biology, anatomy, and even medicine. By studying how traits evolved in the past, we can better understand our own species and the living world we're a part of. So, in a way, when we study the T-Rex and its connection to modern birds, we're not just looking back, we're learning how to move forward.
Oh, that really puts things into perspective. It's wild to think that by studying creatures like the T-Rex, we're also learning about the birds we see every day and even about ourselves.
Yeah, it shows how everybody and everything is connected, no matter how different things appear on the surface.
Well said, everyone. That wraps up today's episode of Steggo, Eggo. Where it's a towering T-Rex or a speedy ostrich, evolution reminds us that the past is always shaping the present. Thanks for joining us as we explored the deep ties between ancient predators and modern birds.